moles, and that's what we actually physically did in lab. The total body of water, plasma volume, being able, and we'll review that for each of them, but that's on there as well, right? So, and then metric conversion. Now, and again, we can review the metric system too, but I just want to kind of just go through quickly kind of what you have to study from each lab, right? In case you're reading thoroughly too. And so, as far as the molar conversion problems, like those 3, 4 steps, you're not going to have them here. So, you know, I mean, it's, you know, I'm going to tell you what you're going to do a molar conversion for. We're going to do it for the osmolarity sheet, okay? But you're not going to have to worry about, you know, 100, you know, 30 millimeter glucose. What is the, you know, the grams or anything like that? No.
Oh, God.
No, or, you know, you're killing people with potassium chloride. I've already done that, okay? So that's not from the first sheet, even though we practiced on that. Are you giving the kids the amoxicillin type? No. Okay? Literally from that first one, and we'll make sure, you know, at some point that you make sure you know it, you're going to have a body fluid question, just like the question on the second page. I'll give you, you have a female weighing this, what's her plasma volume and something else. Okay? 4 or 5 points, that's that. I'm going to have maybe 6 metric conversion problems in which you have, you have 5 millimeters, how many micrometers, something like that. And again, we'll review metric if you need to as well. But there'll be like 5 of those like a point.
So you say like blank millimeters converted to blank meters?
Yes.
Oh, that's easy.
Well, not everybody's easy. But this is the idea. If this stuff's easy, if you got it, this is like 60 points out of 60. There's no, what is my casting? Okay?
Yeah,
so
me too.
that's what it is. Okay, but let's focus, you know, just to kind of get through, because then we can see what questions, what we want to get you over. That's that lab. Okay? Then the next lab we did, or what's the next lab on there? What are these guys should The pH was next? Okay, well, it doesn't matter what's next. We've got the pH and the osmolarity tonicity one. Okay?
Yes.
Osmolarity tonicity one is really big. Let's do the pH though. The pH lab, that's why I went over some of those problems. Okay? Basically, oh actually, hang on a second.
I think they're
I say this.
I have it here if you need.
Yeah. Thank you.
That's such a
I know. Is diffusion gonna be on there?
I want to copy the test.
Oh.
May we have one?
Pretty much. Okay. So, and again, I can go more specifically over each one of these, but I just want to get an overview of what's on the test and what you need from each lab. And then I can help people sort of on it. So, for the pH lab, again, you have to know, basically, and I just kind of quickly do just something here, 7, 9, 5, okay? What is the equation for pH? pH is what? Equal to the negative log of the hydrogen ion concentration, okay? Here's the pH scale. We know that is neutral. When we go lower, it is what? Acidic. And the lower pH number, is that more or less hydrogen?
More.
So it's more hydrogen. Okay? We have that. When we look at this, if we have pH 7 and pH 5, okay, which one is more acidic?
5.
Which one has more hydrogen?
5.
How much more?
2.
No.
Negative log of 2.
So each is a log scale. So it's basically, you know, you count how many divisions. Each is a power of 10. 10 times 7, 10 times 10. pH 5 has 100, I'll just put 100x. 100-fold more hydrogen than pH 7. There's a problem like that, someone on there. So you have to know, again, just what we just said. And you have to realize that the lower pH number means more hydrogen, and that each number is a factor of 10. Okay? And again, I just want to get through sort of overall, but that should be pretty one.
So then would it be negative log times?
No, we're not even going to worry about that. I'm going to show you how we're going to use negative log. This is just a simple problem. Which one has more? We're not going to, I'm not going backwards from pH and figuring out that, because it's not chemistry, that much chemistry. So everyone understand that one though. 2 numbers, the lower number has more, 10 times, whatever. Okay. The other idea that will be on there is a couple of them. So there's a lot of, I'll actually add up the points and tell you how much is on this. But we have this idea of, really acids and bases, but really we've dealt with strong acids. These are the exact problems that you have on this, and weak acids. Acids do what? They add hydrogen to solution, right? Strong acids are complete, so hydrochloric acid completely dissociates into hydrogen ions plus chloride ions. Okay? A weak acid, like acetic acid, basically will dissociate, I'll just write like that, but not completely. So this is 100%, this is weaker, not 100%. Okay? Yeah, that's just, I mean, I'm making it acetic acid, I don't want to draw out the acetate, ion. And you're not going to have to for this, right? And this is the only acids I'm going to give in the test. I'm not like, oh, is this a weak acid, is this a strong acid, what's the pKa? No, let's calm down. Okay? I'm not going to do that.
We just have to be able to identify what's strong and what's weak.
No, I'm going to tell you. Well, put it this way. Yeah, I'm going to put HCl in one of the questions, and that means it's a strong acid, 100%. I'm going to put weak, acetic acid, I'm going to say like 1% dissociates, or 2%, or 0.1%. I'm going to just tell you how much this is dissociated. Okay? And then, that's why you don't need any Henderson, Hasselbalch, or anything like that, because I'm going to tell you. And here's going to be the problem, just like what's on number 4, number 5 on that. If I give you, let's just make it easy. Let's say I have 1 molar of that, and then I have another one where I have 1 molar of weak acid. And I want to know the pH. Which means I need to know the hydrogen ion concentration. So basically, if the acid, strong acid, which I'll give you, dissociates complete 100%, that means what is the concentration of hydrogen ions you just made?
1.
It's the same number, right? That's all you're going to do. Whatever number I give you, that's the number of hydrogen ion, and that's what you're going to put in. Sorry, 1 molar of hydrogen. That's what you're going to put in that equation, negative log of that. Negative log of 1. Okay? And then you come with the pH. I think it's going to be 0, very strong acid, right? But anyway, that's how you do that problem. And that's like, I'll find out, that's 3 points. Okay? Strong acid, you just take that number, you basically take the negative log of it, because it's 100% dissociated.
So log
Times 1. If I had 0.5, negative log times 0.5. Just figure out how to use your calculator. Some calculators, you put the number in and then hit log. Other ones, you basically hit log and they show, you put the number in then. So make sure you know how to do that.
With some calculators, it depends, of course. But are we doing like the log, find the answer, and then the negative of your answer?
That's usually what I do.
Okay.
Because it's going to give you a negative value. You just do the log function and you just change it to positive. Because I don't know how to do the other one. So yeah, so that's the easiest way to do. Just take the log of that number. Okay, who's got that? What's the pH if you have 1? What's the log? The negative log of 1. Calculator.
I have it, but I don't know how to use it. So I'm trying to figure it out. You know how to use it?
Well, that's what we need to do before the test.
Exactly.
Okay? But anyway, when you do that, it's 0, which is strong. Okay? So let me just show you the other one now. So this one, everyone get that one. That's pretty easy. This one's easy too if you're listening right now. So if I give you the percent dissociation, which I will give you, then all you have to do is, okay, whatever that number is, in this case it's 1, but it's not going to be 100%. It's going to be how much of that 1?
Let's do 0.2.
0.01.
I know, okay. You want 0.2%?
Or just 2%.
So that means you do what? It's going to be 1 times 0.2.
02.
This is 0.2%.
Oh, 0.0002.
Okay? I'm glad you brought that up, because some people are going to say it's 0.2%. You have to divide by 100 to actually get the decimal version of it. So 0.2 and then 2 more zeros. So it's 0.002.
So,
Because you said 0.2%.
right.
If it were 2%, it would be 0.02.
Divide by 100.
Right?
Oh.
But you're seeing how now you're converting it to the decimal form. So this was 0.2%. Again, 2% would be 0.02, but this adds another 0. Don't worry, I might put one of those on. That's why it's good you put that out. So although you get partial credit, you just miss the 0. But does everyone get that? That means that 1 times 0.02, that would be your hydrogen ion concentration. Okay? So again, if this were 0.5, you've got to do the multiplication. But that means 0.002. And that would be, you take the negative log of that.
Why
So-
is it 1 times? Just because you, oh.
Because we're saying it's 0.2%, we just made up a number here, dissociates. And so you take whatever that number is,
I just
times
see that number.
times 0.02 in this case, decimal, and that's the hydrogen ion concentration, that's what you plug in. Just like you had on those two problems, whatever they are, exactly like that.
So you take the first number and you multiply by the
Percent, changing it to the decimal. And then you take that number, negative log.
And you're suggesting that we just actually take the normal log of whatever our value is, and then just switch the
The
sign?
sign, because you're gonna come up with like a negative value, and then you make it positive.
Okay,
Yeah,
or if
that's-
it's positive, then use it. Or will it never be positive?
It's not gonna be the other way around. I'm not gonna make it like I'm not gonna make it where it's like a negative number on the
So
first
it's
one.
always gonna be a negative number?
And then you change it to positive, exactly.
Right.
So what would be the number?
Okay, and that's, again, those are, okay, everyone, let's stay focused on that, we'll figure out your calculator later. Okay, everybody, because just for efficiency, I want to, you can figure out how to use your calculator later. I want to make sure we know what problems are on the test, okay? So we're gonna have some problem involving this, simply. We're gonna have two problems exactly like you have on there. One with a strong acid, one with a weak acid, that's how you do it. Okay? Now, let's continue. Everybody don't talk for a minute, okay? I need to sort of stay focused to try to get through efficiently since I have the test. Okay? The other thing is going to be your favorite. Okay? Guess what's on there? Law of mass action, respiratory, metabolic, acidosis, alkalosis. Okay? There's probably 7 points worth of that. Okay? Do you want to review that real quick?
Yes.
No, can we?
What worksheet is that on?
We have it. I don't know. Anyways.
This is the pH
It's
worksheet.
this, no, it's not a worksheet.
It's the pH worksheet. Okay? If you look at the pH worksheet on the back, you'll see
Yeah.
It's the same exact thing as
the especially question like 11
Yeah.
Oh, explain.
and 10. Like questions 10 and 11 work out exactly like we did in class with the law of mass action. But I'm not going to give you the equation. It's not like you have to put the equation on, but you're going to sort of need to do it. So actually, and again, that's going to be, understanding all that is about 7 points. So part of it is almost just like we did in class. Okay? But I want to do that real quick. So, respiratory, acidosis, alkalosis, metabolic, acidosis, alkalosis.
Oh, this is easy.
Okay? We have this, right? Those are the 4. Remember, respiratory, it's called that if respiratory
It's
causing it. Otherwise, if respiratory is responding, it's metabolic. So you do need to sort of know this, I think, to do this, but I'm not giving it to you. You don't have to write it down, but I would, and we're going to use this a lot. Here's the famous equation. Okay? CO2 plus water. Remember, the CO2 side is involving respiration, because that's involving carbon dioxide. This side is involving metabolic. So let's just do 2 of them quickly. Okay, and then people can help. So let's hypoventilate. Okay, we're going to do 3 things. Let's hypoventilate and vomit. Not at the same time. Okay, so hypoventilate, we know it's going to be respiratory, it's causing it. So let's have it cause it. We hypoventilate. Okay, what's the direct effect? Now we're on the equation.
You're losing hydrogen. Oh, you need to hold your breath because you're losing hydrogen.
No, we're starting there. Okay, we're increasing, if you're holding your breath, you're hyperventilating, you're looking at this, you're increasing CO2. Everybody agree? You're holding CO2 in. Okay, by the law of mass action, if we're holding CO2 in, so increasing CO2, which way is this going?
Right.
Because we have too much CO2, we're converting it there. Again, if we were to balance, we've added CO2 because we held our breath, the law of mass action takes us here. What's the next idea that it's taking us here? Hydrogen goes up, pH goes down, and what do we call that condition? Respiratory acidosis. The respiratory system caused it. Okay, and then kidney responds, don't worry, that's coming up, okay, of how it responds. But anyway, that's that. okay? It's understanding this. So in this case, that, hypoventilated, CO2 built up, that shifts to this side, hydrogen is building up, pH is low, respiratory acidosis. That's what it is, okay? Obviously, alkalosis, hyperventilation. I don't have to look that up.
You don't want the kidney response?
No, it won't be there. Or you can write the kidney response if you want, it won't be critical. Okay, I'll sort of guide you through it.
Can you explain one more time why log next section you use it that way? Because I remember you used the balloon one, but that didn't help.
Okay, well, I'm not gonna use that one.
Yeah, no, that's what I was saying.
I mean, there's the seesaw method, okay, but I don't like that one, so I can't do it. For me, the idea is, we were to balance. You got that, right? Okay, now we have too much of this. Now, again, we can't get rid of it right now that way. If we want to get rid of it, we want to add it with water and convert it to that. If we go ahead and can do this reaction, won't that lower the amount of CO2? CO2 combines with water to produce this. That's why it's going that direction.
Oh,
We're getting rid of the excess carbon dioxide by converting it to hydrogen and bicarbonate.
okay.
Okay? And that's one way it goes this way. Okay? Yes?
And respiratory acidosis is what is causing this whole thing to happen.
Yeah, the respiratory system caused the problem. That's why it's caused respiratory acidosis. Okay? And again, you already know alkalosis would be hyperventilation. Okay? Now, metabolic, there's going to just be two, and then we're going to do one of them. Because I'm not going to ask you all the things that can cause acidosis, metabolic acidosis, alkalosis. We'll deal with all those later. Acidosis was that excessive exercise type thing, where you're putting acid, like lactic acid, let's say acid into the blood. That's the only one I use for that. But we're going to do the one example of metabolic alkalosis, vomiting, and that's the only one I'll use for that. So if you vomit, if you're doing metabolic, you're starting over here, okay? And you're going to end up with respiratory response at the bottom, but it's metabolic. Metabolic. If you're vomiting,
Losing CO2.
you're losing hydrogen.
Hydrogen.
Okay? You're vomiting up all that hydrochloric acid. So we're starting over here. Okay? So you're losing hydrogen. Now, law of mass action is going to do what? You don't have
Go
enough.
to the right.
To the right.
You don't have enough hydrogen. How do you get more? CO2 plus water doesn't. So law of mass action still goes to the right. Now, what does that mean for CO2 levels?
They're going to go down.
That means we converted CO2 to that, so we've lost, or we've decreased CO2. And what is going to be the response of having not enough CO2?
pH is.
No, we've already done that.
CO2.
Respiratory is going to respond by
Breathing more.
conserving fuel. It's holding your breath. Okay, you've got to remember that you're breathing, you're getting rid of CO2, you're getting rid of acid. If you don't have enough CO2, you're decreasing respiration to replace the CO2. So, decrease respiration. So, exactly like we had on the other test, basically, but it's on this one too. Okay? And that's the pH.
Oh, quick question on that. Do we, in terms of like oh my god, the reaction, like the equation, are we not concerned with arrows, like stuff? Does that matter as long as we have the points?
You don't even have to put the equation on.
Okay, fine, that's.
Yeah, so, but I mean, obviously it helps to know what I think to do it. But, yeah, I'm just gonna be asking specific questions, going through this, okay? So, and those are the only examples again. Metabolic acidosis will be excessive exercise. Out metabolic alkalosis will be vomiting, hyper and hypoventilation, okay? That's the only four causes of these will do, you'll have that. And that's overall of this concept, that's 7 points. So, the pH lab itself, to actually look at it, has 2 points, 4 points, 5, 6, 7, 8, 9, 10, 12, 13, 15 points are what we just did. Okay? 1/4 of the test involves everything we just did here, but they're the exact problems that you have on that sheet, basically. The exact type problems
On the pH.
on the pH sheet.
pH down.
Okay? Now, as far as, let's just kind of get it, and we'll do the next one. As far as body fluids and vector conversions, let's look at that one. What is my body fluid? Oh, it's 5, 6, 7, 9 points. So we have 9 points between vector conversions and body fluid 1. Okay, pH, we have 15 points. Osmolarity tonicity, we have Whoa. No.
pH is what?
15. We have 20 points, okay? And if you look at this, the test, you know what it looks like? It looks like the first page of your osmolarity tonicity sheet. So I'm going to be asking you, and that's when you're going to have to do the molar conversions. And again, we'll practice if we need to on that, but I just want to make sure we know that. We're going to have, if you look at that sheet, I'm giving you like, and let's just kind of practice one in a way. I'm going to give you something like 1% sodium chloride, and I want to know the molarity and osmolarity. Okay, and then I might give you a second one like on the sheet. You know, we have, I don't know, 10 grams per mil of glucose. And I'm going to want to know the molarity, osmolarity. Okay? That's going to be your molar conversion. Okay? It's not going to be one of those other type problems because you're going to have to do this idea of molar conversions for that. And again, I'll come to this and we can work on that in a second. The other aspect though is the chart. Okay? The exact way we did it in lab as far as having this chart across is what's going to be on it. There's 1, 2, 3, 4, 5, 6 of those. That's worth 12 points, basically going through, again, what is the osmolarity, what is the relative osmolarity, what is the tonicity, water movement, that exact sheet. Okay? And again, we can practice on that. But that's the 20 points. It's exactly like the first page of your handout on it. Okay?
That's when we we draw the cell and the box.
Right. And again, we can practice that for people that want to do that, this whole thing, okay? And some people are going to want to do that. But let's just, right now, let's just see what else we have, and then we can go back. Okay, that's 20 points. So what are we up to? We have 20, 15, what was the first one? 9. That's 44? Is that right?
Yeah.
Okay, so we have like 16 more points? Is that right?
7 for the respiratory metabolic.
The
15 total.
That's part of the pH.
Oh, it is?
That was just part of the pH, yeah. Part of
So
the
pH is total 15 points.
Yeah, that's 44. Okay, then we have two other things. We have the sensory lab, and we have the EMG stuff, the EMG packet. So the sensory lab, okay, that involves that lab sheet. That also involves reflexes. Okay, and yeah, of course I do have the book too. If you remember on that sheet, let's kind of look at that sheet a second. Remember this chart in back? You need to know it. And you need to not guess, okay? When I'm asking, you know, for the patella reflex, what is receptor, don't just say nothing. That's not, you know, there's a real answer to what that stress receptor is. It's in chapter 13, okay? There's specifics of this that you want to make sure you know, and you can check with me on it. So don't just guess on this, because I'm looking for the right answers on this. I said you didn't have to do it then, because, you know, labs are like, let's get home, and you have to wait for it. But that's on there, okay? So before you take the test, I make sure you look at this and you can check with me. Okay, it's not like, you know, you can check with them, but I just don't want to just tell you the answers, because I want you to actually look and figure out the answers, and I'll confirm it. Okay? So that's on there. Okay? The other thing on there, should I just tell you the other thing on there?
Yes.
Okay. The other question on there, the only other one from that lab is the following. And then we just do the EMG stuff. Okay. So the other one involves, let's see if we remember this. This is a 3-point question. Remember, okay, I'm going to have another guy here. There's our fingers. There's his back. There's his fingertips. We're doing this 2-point idea. And remembering the basics is part of that question. The basics idea of more sensitive, what's associated, again, you just had this test, so it's sort of a repeat of this. More sensitive regions, like the fingertips. Okay, What is associated with that? This has a higher what? Higher density of receptors. What
Less,
else?
less convergence.
Smaller true point convergence.
Yes and yes. Smaller receptive fields,
And
less
less convergence.
convergence. The other one, again, you said smaller two-point discrimination. And what's the last one?
Higher representation.
Higher representation of the cortex. Okay? Just like we just did before, that's what you need.
So what, on the lab, you would ask us to list a list like that?
Yeah, basically. I mean, I say there's a question, but yeah, what, name the characteristics of the more sensitive, area versus less, and tell me, include blah, blah, blah. And just the idea is just write those bullet points down. Okay? So, higher density, smaller receptive field, less convergence, I even make you ask that. Smaller two-point discrimination value, greater representation of the cortex. Okay? I mean, describe the relationship between two-point threshold values, density of touch receptors, skin sensitivity, somatosensory cortex representation. All of these must be discussed, but all that means is list these bullet points. Just write that down. And that's all I want. 3 points. Just write it down one more time and you got 3 points. Okay?
Sometimes
Bullet pointed. I don't want a sentence. Tell me about your dad not being able to feel some of his fingers.
What's the say about cortex?
Higher representation. Okay? So those are the 2 things from the sensory lab. Fill out that chart, check the fee. Again, there's the chart, it's exact pretty much, and then just write those bullet points. Okay? There's 4 or 5.
You just want for the more sensitive, or you want
Yeah,
for?
I asked for the more well, I say describe for skin sensitivity, but you can just say that, right? The more you can do the other one if you want, if you're just dyslexic, I guess. But it doesn't matter though. Just pick one and list the characteristics, just like we just did. That's the 3 points. Fill out the chart correctly, that's 5 points. And as long as you come with me and ask me, I'll tell you the right answer. I'm not trying to avoid it. All right? That's all in sensory lab. So what is that more? That's 8 points? I don't know where we are.
You did right, it's like 44.
Yeah, 8 points. That looks like, if I'm right, who does weigh it up? That's 52. And yes, we have 8 points left. Woo! EMG, okay? Well, that's because it's sort of a homework packet, okay? You had to read that 2-page article and answer those questions, okay?
I did.
I did not.
Okay, 2 of the questions, there's like 3 short answer questions. 2 of them involve reading that article, the difference between gender, between men and women. It's like a page-and-a-half article, and you see there's like 4 questions I ask about it, kind of corresponding to each paragraph. Okay, 2 of those.
So you're not gonna ask questions on the lab test
From the video that we can see?
Yeah, you said try to answer them, but don't.
Yeah, it won't, and I'll just answer it for
So
you,
just
but
from the article?
in fact, right now, just for time, I won't even tell you except we did. It's just the article.
Okay.
Okay, so there's like 4 questions from the article on women or something like that, 2 of those.
Okay.
Okay, then there's a bunch of other questions, that are on the lab, and really it's also on that 1-page handout. And one of them has to do with the difference between motor unit recruitment between something like, and we might have talked about this, and now we're just talking about it again, because let's just get that question. We're talking about the difference between, let's say, an endurance runner, or an endurance athlete, and a, let's say, power lifter. So, motor unit recruitment was what? It's basically, recruiting more and more motor units to create more force to do something. But how you do this can be different. And if you are a power lifter, how do you want to recruit your motor units?
Quickly.
Quickly. Like, how about all at once, right? You want maximum power. Do you really care about fatigue? No, you can drop the weight. So we call this synchronous recruitment. All at once. So use synchronous. That's all at once. As you train as a power lifter, but guess what? You actually adapt to be able to do that better. Our neuromuscular system is very adaptable. If you're an endurance runner, you want these all to go at once and then to stop and have fatigue. So you want to do not synchronous recruitment, but
Sub-maximum?
asynchronous. sort of like that. But the idea, you're going to recruit some motor units to create that, then you're going to rest those, and then recruit these others to create the same amount of force, and then rest those. You want to protect fatigue. So we call this asynchronous or alternating type recruitment. So we'll put asynchronous or alternating. That's to prevent fatigue. Okay? That's the one we're taking from that page. Describe differences in motor unit recruitment between a power lifter and long distance runner using specific terminology discussed in the lab and with me. That's the discussion, guys. We can have another discussion later about Breaking Bad, okay? You write that and that's your 3 points. Okay? And you know, this lab test, if you're staying and putting the work in, I want people to do really well on it and get 60 out of 60, you know, help your grade. Again, I have to add up on these, but I'm giving lab points so far, which I don't always do, but it's, you know, the semester is just a certain way, for just attending, right? As long as you're attending, you got, I think this will be the third, should be 30 points already for just attending and doing it, right? There's 2 other ones you turned in that I'm going to catch up on, and this. So, again, if you're struggling with the test, I think you're going to get better at it if you hang in there, and I can help you with it. But hang in there, okay, where you are. There's other points coming, and then we can help you, and you're going to get smarter on this. So don't give up, you know, if you're struggling, and seek my help on this. But the lab test, as long as you put the work in here, you should. And again, I can go back for people that need to. We can go back over molar conversions for people that want to do it, and miss these ones. Those are the ones we can cover. But that is the test. Okay? Any questions about what the test is? Again, you see it up here, in the calculator, it's all written, and you know, I've given you the test. It's you have to make sure you know how to do the molar conversions and miss it, which we can go over. Okay?
Can we go over the molarity and osmolarity 10 grams?
Yeah. So, well, we can 10 grams.
10 grams.
Yeah. We're going to go, that's the page we need to go over. Okay, so just give me a couple minutes. This way, people that want to leave can leave. And I want to rest my voice, and then we can go over whatever you want to. But those are the 10 tests.